Topic 1.3 Materials Evolution. Now I will get you through a period of time starting from the Stone Age through scientific age where we're living now to see how material has been evolved since then. At the Stone Age, people used the stone as the weapon to fight for food, to kill animals, and if you talk about different kind of metals that the human being used for living then, they know gold, silver, and lead. Interestingly, these metals can be found in their native form. It means that you don't need to extract gold from ores. Therefore, people in those days can use gold, silver as their ornament and use the stone as their weapon. And if we move through the Bronze Age, you can see that in Bronze Age, the name bronze named after mixing the copper and tin, and of course being found in the native element too in those days. Bronze is stronger than copper and tin, and this makes weapon for humankind much stronger, and they kill and fight much more efficiently. And when the time passed, moving through the Iron Age, iron and steel are known to be much stronger. Therefore, people in the Iron Age develop themselves faster and can build their empire, as you can see for the example of the Iron Pillar of Delhi. And as we move through the scientific age, as we're living right now, then things changed since from the 19th century. The scientific age made human life much easier, and the evolution of materials goes faster to make our human live comfortably in this social. As you can see now, we have social media, we learning online, we have the mobile phone, we have all the gadgets that we want. And this have thanks to the silicon age and the nano age that I will talk about. There are three different kinds of materials that I will have to mention. First, the advanced materials. The second one is the functional materials or the smart materials. And the third one is the nanomaterials that they are significant in this material evolution in the scientific age. So, for advanced materials, the advanced materials mean only materials and modifications to existing materials to obtain superior performance in one or more characteristics that are critical for the application that we want. And these advanced materials can be made from metal, ceramics, polymers, composites, or everything in combination. From the picture, you can see the solar film that is developed from the solar panel, and with this thin film, you can apply onto your garment or on your appliance really easily. Down here, you can see the hard disk drive or HDD. Then now we'll move on to the solid state drive. And if you look onto this picture, you can see the example of materials evolution that human being can apply all kinds of materials to build the Orion spacecraft. The next one is functional or smart materials. It is also called intelligent or responsive materials, which is designed to have one or more properties that can be significantly changed in a controlled fashion, either by stress, temperature, moisture, pH, electric and magnetic fields, light or chemical compounds. The first example is the shape memory alloy. The shape memory alloy is known to have the ability to change its shape by heating after being strained at lower temperature, and is normally made from nickel titanium alloy. The piezoelectric ceramics generate internal electrical charge from the applied mechanical stress. And the last one is the magnetostrictive materials, which is the materials to have the ability to change their shape or dimensions during magnetization. And the last one that I will show you about is the nanomaterials. You may have heard this type of materials long ago, where they apply nanomaterials, nanoplastics, plastic to our living that we can use nanomaterials much more approachable nowadays in our daily life. Nanomaterials is the materials with its size in a nanoscale, of which a single unit is sized between 1 to 1,000 nanometers, but it is usually in 1 to 100 nanometer and is often had unique properties such as optical, electronic, or mechanical properties. Down here is the example of titanium alloy microstructure before and after being passed through the equal channel angular pressing that make the grain size of the titanium alloy from huge grain size here into the nano size, and that will have different mechanical properties. And the last one here is the carbon nanotube, which is known for biomedical or electrical applications.